This is AQA A-Level Chemistry and we are on the Year 12 topic alcohols. This is video number 2. In part 1 we looked at nomenclature. In this one we're going to look at classification of alcohols as well as isomerism within alcohols. As always, I'm going to recommend that you try each activity, pausing the video as you go, and then review how you've done and you know what you need to look back on in a bit more detail later. So, first of all, we're going to try to classify these examples. Remember that an R represents an alkyl group. If we look at the position of the hydroxyl group in the molecule, this OH is bonded to a C, and it has one alkyl group connected to it. This OH is bonded to a C with 2 alkyl groups connected to it. This OH is bonded to a C with 3 alkyl groups connected to it. So primary is where you have one alkyl group connected to the carbon that the OH is bonded to. Secondary is where you've got 2 of those alkyl groups, and tertiary is where you have 3 of those alkyl groups. So on these, have a go at naming and classifying them. The first one, and in fact all of the names we can see coming straight up, but we've got ethanol, 2 carbons, the alcohol is there on the end of the carbon chain. This is butan-2-ol because we've got 1, 2, 3, 4 carbons in a row. I'm numbering from here and I'm going across because that gives me the lowest possible number for the OH. So that's butan-2-ol. And we have got here 1, 2, 3 in a row with the OH on the second carbon, making it propan-2-ol. In terms of the classification, I'm going to colour code the alkyl groups or where the alkyl groups are connected. So ethanol is a primary alcohol because the C the OH is bonded to has one alkyl group connected. Butan-2-ol is a secondary alcohol because you can see a CH3 and a C2H5 group connected to the carbon that the OH is bonded to. And propan-2-ol is also a secondary alcohol because we've got one methyl and a second methyl group connected to that carbon. Quite a big task here, trying to find all of the different types of isomer of C6H13OH. I think it's really important to note that we've got 2 types of structural isomer that we will see here. They might be chain isomerism, they might be position isomerism. So when you've had a go, have a look at the answers. My first piece of advice is always going to be on something like this, and you wouldn't get this within an exam, but you'd have to pick out some examples maybe, but try to go through systematically. So if I take C6, I can put my 6 carbons in a row, I can put my OH on the end. Can I put my OH anywhere else on a carbon chain of 6? Well, yes, I can put them on the second carbon, and I can put them on the third carbon. I can't put them on the 4th carbon, going 1, 2, 3, 4, because that would actually mean I'm going to number from this end 1, 2, 3, and it would be identical to this final one that I've just drawn. In terms of classification, along with colour coding, we have a primary, because I've got my CH2, 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 CH3 connected. This one is secondary because I've got a CH3 and a C4H9. And this one is secondary because I have a C2H5 and a C3H7. And in terms of the names, we have got hexan-1-ol, hexan-2-ol, and hexan-3-ol, all different positional isomers of hexane. But just because we've done all the ones that are 6 in a row, we now need to consider the branching. Let's consider all of the examples that are a 2-methyl pentane. So let's classify them. We have primary, secondary, tertiary, and another primary at the end. But in each case, although the methyl is in the same position, the OH is moving. So we get 4-methyl pentan-1-ol, so I'm going to number from the OH end, 4-methyl pentan-2-ol, 4-methyl pentan-3-ol, but then we start to flip it over, that if my OH is on the same as the CH3, I number from the left-hand side. So this one becomes 2-methyl pentan-2-ol. And finally, I have 2-methyl pentan-1-ol here, so I'm going to number from this end again. But we're still not done, because what about if we take our 3-methyl pentane branches or chains? And again, I can put my OH on the first carbon, the second carbon, or the third carbon. If I start to move further down the chain, I'm duplicating ones I've already seen. So for these, let's classify them. I have a primary, a secondary, and a tertiary. Colour coding, hopefully helping you see why. And if we're naming them, I have got 3-methylpropan 1-ol, 3-methylpropan 2-ol, and 3-methylpropan 3-ol. I don't have any more methylpentane chains that I can do. But what about butane chains? Well, if I do those, I could put my CH3 and CH3 side chains on the second and third carbons. And I still then have a choice of where the OHs go. This would be a primary alcohol, and this one would be a tertiary alcohol. This actually should be, and I'm just going to put it on there, it's actually this C that's adjacent to the carbon the OH is bonded to, and the alkyl group that comes from there. So once we've got that, we have the names, and we have got 2,3-dimethylbutane because it's on the second and third position. This one is butane 1-ol, because I'm going to number from this end, and this one is butane 2-ol. That means that in total we have got 13 different structural isomers of C6H13OH. And doing that activity gets you thinking about the different definitions, about the different types of isomerism. That takes us to the end of this video. Thank you for listening, and goodbye.